Hello and welcome to the lecture series on automobile engineering. In today's lecture, we are going to look at the operation of overdrive and fluid coupling. Before we take up our discussion on overdrive, let us first look at the classification of transmission types. So among the classification of transmission types, so far we have studied about manually operated selective transmission. Under this, we have also looked at the working principle of constant mesh gearbox, sliding mesh gearbox, followed by shrinko mesh gearbox. In today's lecture, we will study the working principle of overdrive and the fluid coupling. Let us get started with overdrive. Before we look at the purpose of overdrive, let us first look at the transmission system of a vehicle. So here we have a transmission system. Right at the front we have engine, followed by a clutch, then we have a gearbox, then we have overdrive, after that we have propeller shaft, and then we have differential, and then the wheels at the rear end of the vehicle. Among these components of a transmission system, we see that overdrive is located or connected in between the gearbox and the propeller shaft. So now we are clear about where exactly this device is fitting in the transmission system. The purpose of overdrive is to provide high speed to the wheels as compared to that of engine speed. So we have a engine here which is running at certain RPM, and when we engage the overdrive in the transmission system, then the propeller shaft is going to shoot up maybe 3 to 4 times as compared to that of the engine speed. And this kind of situations are very much desirable when we have high speed vehicles like racing cars. Now, because of the advantage of multiplying the speeds, we have the following benefits. The overdrive permits the engine to operate only about 70% of the propeller shaft, which is very attractive, and because of this the engine life can be prolonged, and it is fuel economy, wear and tear can be reduced, vibrational issues can be brought down, and also the operation is not noisy. So these are some of the advantages associated with using the overdrive in the transmission system. Now let us look at the constructional features of the overdrive. So here we have input shaft which is coming from the engine end, and then we have output shaft which will be connected further to the propeller shaft. So we have the input shaft on which we have a sun gear which is mounted. This becomes very clear when we look at the front view. Let us look at the front view. So we have a sun gear right at the center, and the sun gear is in mesh with 3 more gears, smaller gears, and these gears are called as a planet gears, we can see here. Further, the planet gears are in mesh with outer gear, ring gear in other words. So, and we can see that here on the side view very clearly. So this is the planetary gear system we have here in place, and the shaded part what we can see here is a casing, and to this we have output shaft being connected, and the planet gears are again they are held by planet carrier here, and one end of this input shaft has a splines, and these splines are in mesh with freewheel clutch as shown here, freewheel clutch, and this freewheel helps in restricting the power transmission from output shaft towards the input shaft. So it's a unidirectional, so it allows the power to transmit from the input shaft end to the output shaft end, but not from output shaft end to the input shaft end, because of engaging the overdrive, the output speeds can increase much more higher compared to that of input shaft. Therefore this freewheel plays an important role here. Further, the operation goes like this. When sun gear is locked, then we see that the rotation of the crankshaft will be multiplied at the outlet shaft, and when the sun gear is unlocked, then whatever the speed that is obtained at the input shaft, the same speed will be transmitted to the output shaft, so that we call it as a direct drive. So we see very clearly the advantage of using overdrive here. Let us look at the animations to become clear. So here we have a sun gear which is rotating, and this is in mesh with the planet gears, and which are again in mesh with the ring gear, and we have planet carrier here shown, and we see when sun gear is rotating, the RPM at the input shaft and the output shaft, they are same, so therefore this is called as a direct drive. On the other hand, if the sun gear is held constant or restricted its motion, then the speed at the outlet will be multiplied as compared to the inlet shaft. So we see how the speeds are multiplied because of using the overdrive. So with this we have covered our discussion on the overdrive. Now let us move further, taking up discussion on fluid coupling. Again, before we catch up with the fluid coupling details, let us be clear about where exactly this fluid coupling component or a device is located in the transmission system of a vehicle. So we have here again engine and clutch. So in between engine and clutch we have fluid coupling, which is connected here in between, and the purpose of using fluid coupling is to transmit turning effort from engine to the clutch. So this is the purpose that we are using the fluid coupling. Now let us look at the principle of operation of fluid coupling. Let us now take up two fans here. One is connected to the electrical power, the other one is switched off. So when one fan is powered, we see that the fluid stream is going to strike the blades of the other fan blades, then the other blades on the fan will be set in rotation. Thereby we see how the power is transmitted from the driver to the driven without any direct contact. So this is the same principle on which fluid coupling also operates. So here we have two shells, and these two shells are having they are also called as impellers. We have impellers, and these are housed, and in between the two impellers we have some gap here, and the entire housing is filled with the oil. So this is the working medium oil. So one end we have a crankshaft which forms the driving member. The other end we have a driven member which is connected to clutch plate. Therefore we see that the rotation of the crankshaft, since it is in direct connection with the impeller on one half, the driving member, that is the impeller, is going to set in motion, and as it pressurizes the working fluid, that is oil, within the vicinity, and once the required pressure and volume is attained, then the runner wheel or another impeller will be set in motion. So for a typical efficient fluid coupling, there should not be any lag in power transmission. Therefore when the right side impeller is stationary, then we say that the efficiency of the fluid coupling is almost zero. When the rotation speed of the impeller on the driving side, if it is in match with the impeller on the right side, then we say that the fluid coupling is around 99% efficient. Now let us move forward, and we are seeing the fluid coupling here, or a fluid flywheel. This is also called as fluid flywheel because this member forms one of the major part of engine flywheel assembly. Therefore we also call this as a fluid flywheel. So we have impeller on the left side which is connected to the input shaft, so this is the driving member. The other side we have driven member which is connected to the output shaft, to the clutch plate, and it has a splines here. So we see how the fluid is pressing through within the housing. The same part is shown on the side view, where the dark region shows that it is a driving member, and the other part, counterpart, shows it is a driven member. So we have impeller here, and other side we have a runner, in other words. So this is about the working principle of fluid coupling, and these couplings are popularly used in automatic transmission systems, majorly almost in the vehicles of advanced technology. So with this we have come to the end of today's lecture. Thank you for your attention.